Yeah, I want to call our next speaker to the stage to talk about AppSec is more than application security. The founder and chief technology officer of Checkmarx, Maty Siman. Maty, the stage is yours.
Thank you for joining me today. I've been in the software industry for more than 35 years. I got my first computer at the age of 7. I started developing in BASIC, and I'm writing code every day since. The industry has changed drastically over the last few decades. I think the most notable change happened about 7, 8 years ago, where developers, with the introduction of cloud-native development and so on, developers started to become curators rather than just only code writers. At the beginning, at the early days, developers just started writing code, void main, and the entire code base. And again, about a decade ago, there was a shift, and developers needed to start choosing which components to use. They didn't write everything on their own. They had to choose from many different components, web services, different services, third-party components, second-party components. So their challenge was to choose the right component or the right tool for the task. A term that I really like is called Legolizing, choosing the right blocks and to combine them together. Now, if I watch my daughters build a bridge with Lego bricks, and they want their bridge to be safe, to be stable. So there are two things that they need to do. First of all, they need to make sure that they choose the right blocks, just choose the right blocks to build the bridge, to make sure that these blocks are not broken. A broken block will break the bridge. But that's not only that. Even if they do choose the right blocks, the way that they combine the blocks together will tell if the bridge is safe, stable, or not. With the very same blocks, they can build a stable bridge or an unstable bridge. So again, wrapping up, in order to build a safe bridge, they need to make sure that they choose the right blocks, which are strong enough, and then the architecture of the bridge needs to also be sustainable. And same goes with application security. With security, you need to choose the right components, the AWS or GCP or Azure services, or Okta, and the open source components, and the third-party closed source components. And on top of all of that, you write a fairly small piece of code that represents your unique bridge, your unique software. To make sure that your software is secure, you need to check each individual block and also the overall architecture of your software. So the first bold statement I want to make here is that the term AppSec, which we are all familiar with, which stands for application security, is probably no longer relevant. Maybe it should change into product security or software security. So AppSec is beyond application security. It should treat not only your applicative code, but the entire bridge, each of its components and its architecture. Just as an example, 10 years ago, network security was the responsibility of the IT team. They were running around and connecting cables. And today, cloud security is the responsibility of both the cloud vendors, like AWS and GCP and Azure, but also of your developers. With infrastructure as code, they're writing the code that provisions their network, that provisions the IT. So the responsibility is shared between the cloud vendors and your developers through the code they're writing. And this is very much aligned with the shared responsibility model by AWS, by Amazon. Okay, they own some of the responsibility, but your developers own the other part of that. For those of you who are less familiar with infrastructure as code, just a couple of bullets in here. So instead of, again, running with cables and connecting servers around, with infrastructure as code, you write a code that defines your network. So you can have multiple versions. You can have a high season version of your network and a weekend version of your network. And you can just switch networks as you switch different versions of your software. There's the concept of don't fix, redeploy. If there's a problem with your network, much like you do with software, you just restart it. So you kill your network and you relaunch it, and boom, you're saved. And so on and so forth. So it means that the responsibility over your network shifts left from your IT team and maybe the DevOps team, shift left to the developers. Now, the developers don't know how to build safe and secure networks. It's something that is relatively new, again, a few years ago. And developing infrastructure as code uses the best development practices like CI/CD and GitHub and containers and so on and so forth. Just as an example, we all know of SolarWinds. They haven't released yet exactly how the attack took place. One of the rumors is that they left credentials open in one of their configuration files, network or FTP configuration files in GitHub. And then hackers were able to retrieve these credentials and modify the binaries on the FTP server. As far as you remember, the password was SolarWinds 123, not too hard to guess. But again, it was a software vulnerability. It was left in their software code, but not in their application code, but in the infrastructure and configuration code. So that's why I think that AppSec is beyond application security. So we agree that for application security, we need to scan the application code, and then the infrastructure code, and then the third-party component code. This is the analog of my daughter checking each individual brick, making sure that each of the blocks is strong enough. But as we agreed, it's not enough. As I agreed, it's not enough. We need to see how everything is combined together into the overall architecture. So the plus sign here is not very accurate. It should be a multiplication sign because a holistic approach here is needed. It is very probable that there is something in your code which is okay, and there is something in your infrastructure code which is also okay, but when you combine these two together, only then a vulnerability manifests itself. So just by looking at each individual component in here, everything is okay. The combination of the two or the three leads to a vulnerability. So a holistic approach is needed. Just a few examples in here. So that correlation layer, which takes inputs from various places, might allow you to tell you whether a specific result in your application, a vulnerability in your application, is indeed exploitable or not. For example, there is an input that comes from a user, but there is a mitigation measure like an API gateway in there. It helps you to find additional results that manifest themselves only with a combination of multiple scans. And it helps you to build a threat modeling. Just as a couple of examples, I will run these slides real quick. The resolution here is not too high, but here we see a threat modeling of each individual component. So we see the vulnerabilities in your code, and the vulnerabilities in your open source code, and the supply chain risk of the components you're using, and the risk of each of the AWS services you're consuming, S3 or SQS or you name it. But nothing is connected. You just see different islands, and it tells you the strength of each individual block. But as you move forward with the correlation layer and you're able to correlate things together, for example, you can say that your application stores sensitive data in a publicly accessible S3 bucket, okay? Your application stores sensitive data in a publicly accessible S3 bucket. Two different scanners, your SAST scanner, Static Application Security Testing Scanner, and your infrastructure as code scanner, combined together with a correlation layer, and only then you can say, well, this is a high-risk vulnerability. Because if I store non-sensitive information, this would be okay. Or storing sensitive encrypted information in a private bucket would be also okay. Only the combination of the two manifests the vulnerability. And same goes with API, whether it's externally exposed or not, and so on and so forth. And then you connect to other microservices and other microservices. So you can zoom out of that threat modeling to see how everything is combined. So this is a challenge and an opportunity for the industry. The challenge is that each piece might need to use a different set of engines to scan, and then the results need to be correlated or meshed up. So that's the challenge. Once we solve that, the opportunity is that we're able to converge all the different tools and processes and stakeholders into just one. So you connect your system to a repo, you scan all the code, whether it's third-party code, your code, or infrastructure code. and you get a single pane of glass telling you all the issues with your software, not application, with your software. This is a good opportunity to introduce an open source free product called Kix, Keep Infrastructure as Code Secure. We have released it in February, almost 6 months ago. Free tool, you're very welcome to use it to scan your infrastructure as code. We have over more than 250,000 downloads over Docker Hub, so you're very welcome to download it, and you're even more welcome to contribute your best practices, your infrastructure knowledge, and to share it immediately with a fairly big community of 250,000 users. It supports all the following technologies for now. I guess there are a few that I haven't added in here. And there are more than 1,600 different queries, different rules. So you can extend it and just to make sure that your infrastructure as code is secure. And with that in mind, just remember that AppSec these days is beyond application security. Thank you very much.
So this is a very interesting concept, moving from application security to the next stage of connecting everything together and scanning the platform. So my question is, well, I have two questions. Number one, what are common problems that you see? What people are doing wrong, and how maybe your solution solves this problem?
It's a good question. The challenge that we see is that developers need to, they're polyglot and polytech, they need to know so many technologies, and very often they're left behind in the tech stack. They don't really know all the vulnerabilities in the technologies they're choosing, and with Checkmarx, that's our responsibility to stay ahead of the curve, know all the security issues that are in different technologies, to scan their code, the developer's code, all the code that I've mentioned, and to find their vulnerabilities. So we provide them actionable data regarding their security risks in their application, in their software.
Okay, perfect. So I have a bigger question for you. Right?
Okay.
People are doing every type of scan that they can on their code, on the systems. You see big developers like Microsoft, Apple, and others doing everything that they can to issue secure systems to the public. Eventually, bugs are being found. Hackers exploit vulnerabilities and so on and so forth. So where do you think this world is going to? What is the future of releasing products, code scanning, and releasing more secure products to the market?
So I think that one of the hottest topics today is the supply chain. It was mentioned in previous sessions. There was a recent attack with Microsoft, I think it was with their Hello product, that a hacker just manipulated, or a white hat hacker manipulated one of the open source components they're using, and eventually this code was introduced into Microsoft product. So I think that supply chain building credit score for developers or different contributors and for repos is something that will gain great momentum over the next 12 to 18 months.
Perfect. Thank you so much.
It's been a pleasure. Thank you.
It was our pleasure.